Hey guys, today we're working with arithmetic sequences. And if you see it says I can identify and describe arithmetic sequences. And this is the vocabulary that we'll be working with in this chapter. So example one. There we go. Example one, it says connect sequences and functions. So let's see what that means. So if we have a list of these numbers, 26, 39, 52, 65, 78, it's asking, is the ordered list an arithmetic sequence? So what we do is we look and see if there's a pattern. So we find the differences between them. If you look from 26 to 39 to 52 to 65 to 78, each time you're adding 13. If you look down at the screen, that's what that adding 13, adding 13. You can even put a plus sign in front if you want. And we're going to use this to talk about what an arithmetic sequence is and a lot of the vocabulary that goes along with it. So first things first, a sequence, what that is, it's an ordered list of numbers that forms a pattern. What's next? Each number is a term of the sequence. So each of these numbers is a term. So the first number is the first term of the sequence. In an arithmetic sequence, the difference between any two consecutive terms is called the common difference. So what we did here when we found the common difference between 26 and 39 and 52, we found that the common difference is 13. So because it's the same, there is a common difference of 13. It is an arithmetic sequence. That's the whole point. Part B says, how are sequences related to functions? So everything we've been talking about is functions. So why are we bringing up sequences now? Well, now I'll connect it for you. If you think of a sequence as a function where the domain is the natural numbers and the range is the terms in the sequence, that's your function. So for example, the last one we just worked on, 26, 39, 52, 65, 78, the n is the term in the sequence. And a of n, just like f of x, a of n is the value of that term. So for example, wrong button. For example, a of 1, the first term, is 26. A of 2, the second term, is 39. All right, so more facts. The next thing we need to talk about is how do you represent sequences using subscript notation. So this is just like, so you understand what this means. If you see a subscript 2 equals 39, that just means the second term is 39. You can either use the one I just showed you, function notation, or subscript notation to represent sequences. I usually like this way. I think it just makes more sense to me. So now let's try it, make sure this makes sense. A of n is the value in the nth term of the sequence, 26, 39, 52, 65, 78. Is the domain of the function continuous or discrete? Explain. Pause the video and then hit play. So the domain of this function is 1, 2, 3, 4, 5, and so on. The domain is discrete because each term can only be represented by a natural number. Remember, we said domain back here. It says the domain is the term in the sequence. So that's why it's just 1, 2, 3, 4, 5, and so on. It's the term. You can't have 1.5 terms. There's no 1.5th number. It's just 1 and 2, the first and the second. All right. Now, determine if the sequence is arithmetic. If it is, then find the common difference. So this is another example. Pause the video, see if you can figure that out, and then hit play. So if I look from 95 to 90 and 90 to 85 and 85 to 80, there's a difference of 5. So the common difference is 5. And that means, because it's all the same, that it is an arithmetic sequence. So here's the definition. Recursive formula, that's what we're working with. It means that it happens over and over again, and it relates to each term in the sequence from the previous term. It is composed of an initial value and the rule for generating the sequence. So your first term is a sub 1. That means the first term. The nth term, meaning any term I give you, that's a sub n equals a sub n minus 1, so 1 before it, plus the difference. So that if you see these little tags, this is saying that's the first term. A sub n is the nth term. This a sub n minus 1 is the previous term. And then the d means common difference. Down here it's saying the recursive formula describes the pattern and can be used to find the next term. Only the next, not any term, but the next. So that's just found in your book and in our vocabulary. So let's move on a little bit. We're talking about how do we apply it now, because that's the point here. And we've got this pyramid. What is the recursive formula for the height above the ground for the nth step in the pyramid shown? Each step is 26 centimeters tall. So what do we do? Well, we know the first step is 26 centimeters. So all that means is a sub n equals a the n minus 1 plus 26. That's it. That's your answer. It's saying whatever the previous one is, add 26 to it. All right, and that's what I'm kind of blocking you here. The formula gives the height above ground for the nth step with a sub 1 equals 26. All right. So the second part to this, that's just the answer I just told you. You use the recursive formula where a sub 1 equals 26 to find the height above the ground for the third step. Well, first thing is we got to find the second step. So what we do is a sub 1 equals 26. That means the second step is the first step plus 26 more. So the second step is 26 plus 26 because the first step is 26. So that means 26 plus 26 is 52. So the second step from the ground is 52 because the first step plus the second step, sorry, you can't see my hands, the first step plus the second step is totally 52. So now that we know the second step from the ground is 52, all we got to do is add 26 to get that 78. So that means the third step is 78 centimeters above the ground. That's what it says down here in the bottom. All right, great. What's next? Try it, pause the video, and then hit play. So number 2 says, write the recursive formula to represent the total height of the nth stair above the ground if each stair is 18 centimeters. So same concept. So a sub n equals a sub n minus 1 plus 18. That's your answer. So that will stay consistent. All it's asking is what's the d value, the difference, and the difference is 18. Each stair has 18 centimeters, each step. Okay, the next thing is just a definition, and this is the explicit formula. This is at any term, nth term in a sequence. So this one's a bit more valuable, but we kind of need the first one, the recursive, to understand the explicit. So that's why we show you both. So this one is saying a sub n, so any term, equals the first term plus the term number minus 1 times, in parentheses, times the common difference. So this is just a formula for you to have. How are we going to apply the formula is the important part. So get this down. The cost of renting a bicycle is given in the table. How can you represent the rental cost using explicit formula? So the number of days rented, 1, 2, 3, 4. Each corresponding day rental cost is 226, 38, 52, 62. This really reminds me of slope now, right? So if I look, what's the common difference? What's happening? It's going plus 12. So that means D equals 12. And what's my a sub 1, my first term is 26. Both of those is exactly what you need in order to solve this, in order to write the explicit formula. So let's move me. Here we go. So a sub n, we're using the formula. What's the first term? It's 26. So that's why in blue you see 26. Plus n minus d times n minus 1 times d. What's d? Well, that's the common difference. That's 12. And then what's n? Well, n is any term, so we don't know. It's going to depend on the term number you're looking for. So then you distribute the 12 to the n, that's 12n. You distribute the 12 to the negative 1, that's negative 12. 26 minus 12 is 14 plus 12n. That's my answer. A sub n equals, this takes forever, but that's okay. So right here, a sub n equals 14 plus 12n. That's the rental cost for whatever I put in for n. Awesome. Did I hit that by accident? Okay. Hopefully you can still hear me. So now there could be a second question, something like, what is the cost of renting the bicycle for 10 days using the formula? So now what's 10 days? That's renting the bicycle. That's my n, right? That was the first part of my chart. So I plug in n for 10. A sub n equals 14 plus 12 times n, and that's 134. So that means it costs $134 to rent a bicycle for 10 days. And part C, how does that formula relate to a linear function? Well, what I'm looking at here is my slope is 12 and my initial value is 14. That hasn't changed. That's the same thing.
Afternoon announcements.
So if you plot these points, right, say here's a coordinate plane, and days we went by ones, we just didn't write every other one, and costs we went up by 20s, actually we went up by 10s, we just didn't write every other. So if we plot the points 126, 238, 350, 462, you see they're on a straight line. So f of x is the same thing as y equals 12x plus 14. So again, slope 12, y-intercept 14. All right, so now I'd like you to pause the video and try it. The cost of rent a bike is $28 for the first day plus $2 each day, slope each day. Write an explicit formula for the rental cost of n days. What's the cost of renting a bike for 8 days? So first, let's write the formula. So the formula, I'm looking at $28 for the first day. So that's my a sub 1, and then $2 for each day after. So the formula is a sub n equals 26 plus 2n, my slope, each day after, 2n. The cost of renting a bike, well, I've got to do the math. I do 2 times 8, that's 16. 16 plus 26 is $42. So there we go.
Excuse me for the interruption.
All right, so there's only one more thing we have to learn. It's example 4, writing an explicit formula from a recursive formula. So sometimes we're going to have recursive and we need to translate it. That's what that's saying. So we've got this, sorry, I'm blocking. We've got this stairs here. All of their steps are 4 inches tall, but the first step is 7 inches tall. So the recursive formula for the height above the ground for the nth step of the stairs shows a sub n equals a sub n minus 1 plus 4 with a sub 1 equaling 7. So as I just explained, what that means is the plus 4 means all the steps are 4 inches tall. But sometimes the first step is a different amount. So in this case it's plus 7. It's 7 inches tall. What explicit formula finds the height above the ground for the nth step? So let's see what we're supposed to do. So first and foremost, a sub n, this is like just our facts that I've now repeated too many times. And so what do we do, right? What do we do? So we use the explicit formula. We plug in 7 for a sub 1. We plug in 4 for d for our difference. And then we just substitute, I'm sorry, not substitute. After we substitute, we just distribute. So 4 times n is 4n. 4 times negative 1 is negative 4. And then we should get... It's saying it's fine, you don't even have to distribute. But if you did, you would get 4n plus 3. A sub n equals 4n plus 3. This is it. Pause the video. This is your last try it, and it says it's not just the try it, but the last try it. Yeah. So write the explicit formula for each arithmetic. I only have one. So for the only arithmetic sequence. So same idea. If we have a sub 1 equals 10, and we have the formula here, a sub 1 minus equals a sub n minus 1 minus 3. So what does that mean? That means that our common difference is negative 3 and our initial value is 10. So we take that and we use the formula and we plug in a sub 1, we plug in at 10, and for d we plug in negative 3, right? And that's your answer, but I did distribute and get my final answer of a sub n equals 13 minus 3n. All right? That's fabulous. Perfect timing. Have a great day.